Alright, we have a 5-liter sample of chlorine gas at 2.2 atmospheres, compressed isothermally. That means the temperature is held constant to a volume of 0.100 liters. So we go from 5 liters down to 1/10 of a liter. What is the pressure of the gas at this volume? Alright, so if we take a look at this, we don't see anything about moles or grams or number of particles, anything like that. So what we're looking at here is a PV over T equals PV over T problem. It's not a PV equals nRT. Because take a look, check this out. So we have a sample, say at this point here, it's got a pressure, a volume, and a temperature. It's 5 liters, 2.2 atmospheres. Well, look at that, constant temperature. So it's the same temperature. We're going to move that to some new set of conditions with a pressure and a volume and a temperature. We can call this 1 and call this 2. Okay, so we know the relationship. We know that P1 V1 over T1 is equal to P2 V2 over T2. Or we can also say, we can rearrange this and we can say P1 V1 times T2 is equal to P2 V2 times T1. But check this out. Since the temperature is the same, we really don't have to even worry about the temperatures. We can get rid of them because they're the same number, 6 and 6 or whatever they happen to be. It doesn't matter. So that simplifies. So let's see. P1, what do we have? 2.2 atmospheres. And V1, 5 liters. And P2, what do we do? What is the pressure? So we don't know. And V2, we do know that. It shrinks down to equals 0.100 liters. So even before we solve this problem, we know which direction this pressure is going to go. If the pressure goes, if the volume goes from 5 liters to 1/10 of a liter, what are you doing? You're shrinking down the volume. And so if you're shrinking the volume and the temperature is remaining constant, then you know that your pressure, if your volume's going down, your pressure is going up. So we should expect a higher pressure. Well, let's go ahead and put this in there. So P1 is 2.2 atmospheres. V1 is 5 liters. Is equal to P2, which we're solving for, times V2, which is 0.100 liters. So P is equal to 2.2 atmospheres times 5 liters all over 0.100 liters. So if we use our handy dandy calculator, and what do we have? 2.2 times 5 divided by 1 equals P equals 100. How many sig figs do we have? 2. 10 atmospheres. That's pretty high. Now we have an ambiguous 0, so I guess officially we would probably want to say 0.1 times 10 to the second atmospheres.